understand what problem you're trying to solve with those systems. And one of the key things is every time you've got to make a hole in the building envelope, you want to think very carefully about, do we really need to do this? Is this the smartest way to do it? You're not just making a hole to run some ducting, to pump some air in, you're also displacing insulation and creating all these other potential issues.
Hello everybody and welcome back to another episode of the Build Insite Podcast. Today we have joining us the co-founders Andrew Pickard and Hannah Angus from Powerhaus Engineering. Andrew and Hannah, can you give our listeners more of an insight into Powerhaus, the services that you provide, and tell us a bit about the app?
Thanks guys, thanks Luke and Dean. Hi everyone. So for the last 15 years, we've been working with industry professionals and homeowners to optimize buildings and to get better outcomes. And it's sort of grown from there in terms of working from the design stage all the way through to developing details and even doing quite a bit of testing of buildings as well. So the implementation stage. So our services start from doing energy assessments and dealing with some of the compliance framework challenges, and then going further, looking at different pathways through the compliance framework, which has become more of a challenge as 7 stars comes in, and there's also been some issues around alterations and additions in different jurisdictions.
So Andy is the expert, the energy efficiency guy. So his head's always in the details. I joined the business about 3 years ago, and around that time, we started asking questions like, what are we in this for? What are we really trying to do? And that's when we got clear that our mission is to try and help people build homes that are part of the climate solution. And that's also when we started looking at what information we can get when someone does an energy efficiency rating, a NatHERS rating, and ask questions around, how do we help people make good decisions? What does this information tell them, and how do we take them on a journey with it? And that's when we started developing the Powerhaus app. And what that does is it starts to put together the picture of the data from your star rating, which is the amount of heating and cooling your house will need, with your energy efficiency information about your appliances, and also where your energy is coming from. So solar, and how it compares to that overall use.
And there was a couple of problems we wanted to solve with that. One of the main ones was we wanted to move away from these sort of compliance frameworks and actually empower people with this data to have an impact on what they were building, and also what the future energy needs of their building are going to be like. And then also this challenge around communicating this to people. And what we were trying to create is this aha moment where people are actually able to see and visualize this so that they are in control of the data and have an experience of, oh, this type of heating system is going to reduce my energy bill by 50%, and they can see that. And I think partially just the challenge of working for nearly a decade and a half and communicating this, we realized, we're repeating a lot of this, and the challenge here is to take people along on the journey and empower them with that information. So, we're really trying to put it together, move away from just the compliancy limitations, and make sense of it in terms of a broader picture of, well, what is the vision for this house, and what are you trying to achieve here, and what will your energy needs look like in 50 years' time, and how much is this house going to cost you to run when we've transitioned onto fossil fuels and you've got a lot of solar available in the middle of the day, and in wintertime you've got bigger bills and less energy.
It's so amazing, guys. And the aha moment, even just going on your website, seeing how helpful the website is eye-opening for what the amount of information that people need to take in these days. And probably crossing over, talking about information, we talk about high performance in building these days. So high performance building techniques. We're talking wraps, we're talking air tightness, optimal insulation levels, quality windows, and the performance of them. So in your time, guys, like what's changed? And like especially now this year, we've seen the NCC finally brought in. I know Lukey and SA's just got it this month. From your position now, like what's changed, and what do people need to do to ensure they're complying?
Yeah, great question. I mean, there's a couple of different things that have come in the NCC, so it's important to sort of talk about that. And also we've got all these different climate zones and different things are being brought in, but I guess the key pieces are a shift to a higher level of thermal performance, which is essentially a measure of the building fabric and design. And then there's also the condensation and moisture provisions, which really hit the detailing question that you asked there, Dean. So they're probably the key pieces that really relate to the work that we're involved in. Then, and that goes as far as, well, how do you manage the venting of a roof space? And there's some really tricky details that have come up around that and are causing quite a lot of issues. It's tricky. But the main thing, increase to 7 stars. And what that's actually meant in real terms is about a 20 to 30% increase in thermal performance. And it's not linear. 6 to 7 is not the same as 5 to 6. It's actually exponentially harder. So what it fundamentally means is people need to repattern their thinking of an energy rating being a piece of compliance paper that you get at the end that's a tick box. And now you need to think about this even before you're developing a design. So once you've got sketches and you've got a floor plan and you've got rough window openings and zones and shading, that's when you need to engage with this. And just need to start getting feedback and sort of, I guess, benchmark it and then work out, well, what's this going to cost me to build? Am I even going to be able to build it? And, one of the things we talk about at that stage is the level of difficulty of that design in that climate zone, and try to help people understand, okay, you've designed X, so it's going to mean this, that, and that. And I could talk all day about this.
I'm hearing collaboration there, Andy.
100%. Nailed it.
The other thing is we are finding that more and more people are asking questions about this and comparing not just, what's changing in industry and with standards, but questions around what is a good building? Should I do a passive house? Should I aim for 8 stars? Should I aim for 9 stars? Healthy homes. I would just say the industry is really picking up on this, and we're seeing a high increase in the number of builders who are coming to us saying, hey, I'm just trying to figure out what does good look like.
What's a good home now?
I looked at passive house, I'm thinking about it. It seems quite expensive. I'm looking at star ratings, like, we're putting on solar, but what does that even mean? What is a good metric for a home? And how do I walk through this new world?
I guess that also then leads into carbon footprint as well. We were speaking a little bit off air before this, Andy, about another video that I'd listened back to earlier this morning that you did with a coaching group that I'm involved in, and there was a term that you used in there about net zero energy usage, and you referred to it more of you need to achieve a daily net zero energy usage. Can you explain a bit more about that, and I guess how we sort of transition our homes into off of fossil fuels?
Yeah, perfect. There's a couple of different pieces here. So you've got operational energy and then you've got embodied energy. And operational energy is once that home's built, what are its energy needs to keep the occupants comfortable, healthy, safe, and run all your appliances and hot water. And I would add to that, do some of your domestic transport in terms of energy. Obviously EVs are going to be a thing at some point. That's a whole other conversation. And then you've got embodied energy, which is how much energy did that structure take to build, in terms of where did those materials come from? How far did they have to travel? And that's something that's coming into play. But I think it's a few years off, but there's the groundwork for that starting to happen. But in terms of this net zero and monthly net zero, the kind of key metric that gets thrown around is net zero. And that's a measure of, okay, over a year, this is how much energy we produced from rooftop solar on that building, and this is how much we used for operational energy. And that's typically talked about as the goal. So you want to make more than you use. And certainly the way we look at this is, well, that doesn't really make any sense, because you can't store additional energy that you make in the summer and use that in the winter. It's not how a battery system can operate. You can't do that. There are some clever ways of storing energy in mass and different things. It's being explored in Europe. And again, it's a great rabbit hole we could go into. But the kind of standard that we talk about is looking at your seasonal needs. And so monthly, month by month, across the year, can you produce more energy than you need on average? And that way, you're actually designing the house for its climate. So we don't have a net zero metric within our platform, but we have a monthly net zero metric.
Well, it's daily.
Oh, sorry, daily net zero.
Daily.
Yeah. Daily net zero. So you can see, okay, in the middle of winter, this is a real challenge here. This house can't produce as much solar because of where the sun is in the sky, and our needs for heating have gone up. And that's true for the majority of Australia.
The thing we think is really powerful about daily net zero is it tells you two things. One is, how sustainable is your energy supply? Can you produce on a day the right amount of power to power your house? And when you look at it, you'll quickly see that pretty much everyone in Southern Australia can't, because we have huge heating needs that blow out our energy budget.
I need to jump in here for a minute, guys, and take a moment to thank our sponsors, Backman Builders, Calorie Building, and Build Imagery. Without the support of these businesses, the Build Insite podcast wouldn't be possible. So jump over and show the support for them so they can continue to support the Build Insite podcast.
So now you've got this information. You can actually think at design stage, can I change the framework of my house? Can I change the materials I'm building with? There's all these different levers to tackle that challenge. And that is basically moving towards, I guess, the goal. And the goal is zero carbon. So there are no fossil fuels used in the production of energy that powers my house. But daily net zero is basically, on a daily average, I now have the levers to try and manage that better. And the flip side, if you're not even interested in sustainability, is this same metric is telling you, can you run your house for free?
Yeah, it's
more or less, you don't actually, what we love about it is it's like win-win-win. It doesn't matter what ethos you're coming to this decision with, it's a great outcome.
Yeah, that's exactly right. There's triple bottom line stuff going on here, and it really starts to paint a picture. And so we are kind of cautious about overemphasizing or just highlighting that this makes fundamental sense. And if you can design a house that's providing its energy needs year round, and we're not talking about doing this by just heaps of rooftop solar, I think that again is going too far in a particular direction, because then you have all this wasted energy in summer, and that then becomes an issue for the grid. That power gets throttled and it's wasted. So it's a delicate balance, and it's also something that seems to be largely overlooked, and it's the kind of the key piece in terms of putting together these metrics and the framework.
The other thing, I'll just add, is star ratings are on a per square meter basis. Yeah. So your efficiency is the same whether you build a small house or a large house, whereas the amount of energy you need to power that house is directly proportional to the size. So when you're looking at the daily net zero, what you actually see is the total amount of energy for that house compared to the same standard across the board, which we start with the 6 kilowatt solar system. And so now you're actually seeing the footprint of the house in real terms, rather than star ratings, which are designed to make things comparable, if that makes sense.
I love that. We've all got an angle to come from, regardless of, I suppose, your opinions, whether it's sustainability or we all have a back pocket.
Yes.
So, I think at the very least, energy efficiency, it has a great emphasis for people, especially families and stuff, with the cost of living so high in Australia. that, you know, you can save money. But, you know, speaking on energy efficiency, fossil fuels, I know just building homes in climate zone 6 and 7 for all these years, and quite often we would have probably have done houses, you know, before you know better, that would have had hydronic heating, fireplaces, split systems, you know, typically potentially up to 3 different sources of heating in that home. So I think with what we know now, guys, what would be some do's and don'ts when it comes to heating and cooling our homes?
Have a plan, and then understand what problem you're trying to solve with those systems. And one of the key things is every time you've got to make a hole in the building envelope, you want to think very carefully about, do we really need to do this? Is this the smartest way to do it? You're not just making a hole to run some ducting to pump some air in. You're also displacing insulation and kind of creating all these other potential issues. So, and I think the other key piece that I'd bring in is heating recovery ventilation systems. And the reason I talk about these is they kind of hit some triple bottom line stuff as well. They mean that you can run a split system in a particular room and size that system for the whole house or an area of the house, and then use a heating recovery ventilation system to slowly spread that comfort. And this way you are having a much less impact on displacing insulation, moving air around. And there's some sort of theory, some big picture theory here, and that is if you've got a lot of air moving around, it's going to cool you down and you're going to feel cooler. So blowing air at people in summer is really effective, and split systems are excellent, as are fans. And split systems and heat pumps, they use 30% of the energy that a radiant style heat will use. So it's really the future. So we're talking about heat pumps here, and you could use a heat pump to heat a slab through hydronic heating as well. And again, if you're going to heat a slab, it needs to be thermally broken and decoupled from the ground. But certainly not using radiant style systems. And when I say radiant, I mean 1-to-1 electricity.
Bar heater, panel heater with an element in it, element spaced in your slab, any of that is radiant heating. And so we are just huge proponents. You start with a heat pump, and a heat pump is a split system. We also mean heat pumps for hot water.
And hydronic heating as well. It is radiant, but a heat pump. Yes, it's very complicated. We're getting in the loop now.
I love how you two bounce off each other.
I tried to get him to answer this question clearer before we went on the podcast. Okay, so basically, do your heat pumps, do your split systems. If you do air tightness as well, that's a lot of people complain about split systems, like, oh, they don't actually heat, they make me feel cold. And likely you have experienced a split system in a leaky house that has high air leakage. So the split system is working constantly, blowing hot air at you, and then that air is leaving the house. So it's got to work all the time. When you experience a split system in a house that's quite airtight, we live in a house that we've retrofitted to around 2 air changes with a split system. It is actually really effective. You can heat the air up and then turn it off if you like, and leave it for a couple of hours until you cool down and want to put it back on. So heat pumps, super effective. That's also the thing that we find when people use our app and they look at the cost of their energy bills and the way that drops if you compare using radiant heat to a heat pump, and you go from this huge heating load to 1/3 of that, or even 1/4, depending on the efficiency of your system, is huge. This is going to change your experience of your energy bills.
And following on to that, a heat pump that is designed for that climate, because these machines, they're basically little engines, and they gather heat from the outside and bring it inside when it's winter, and then the reverse in summer. And if they are not designed with an efficiency that's appropriate for that climate, they're not going to work well. And this is kind of tricky because it's not specifically stipulated what its range of its performance range is at that temperature necessarily. So there is a big range in heat pumps, and what I would also say is they've been used really effectively in North America, in and much colder places than Australia. So, but some of the older heat pumps, they weren't up to it in terms of the efficiency of the cycles that they could produce, and so they weren't as effective. But that is not the case anymore. So heat pumps are a fundamental part of this, as is really trying to minimize disturbances to the building envelope, and fitting that into a bigger plan or strategy for, okay, how are we managing potential overheating? How are we going to manage a cold day in winter? And it really fits part of the plan of the building and needs to be considered when you're designing that building, because buildings will have different needs, and they are really kind of a dynamic. That they're not a static sort of organism.
I wonder too, Hannah, how many people would think their split systems aren't working properly and they're not cleaning their filters out. I think that'd be a common one. Just magically supposed to clean themselves.
Yeah.
Continuing on, sort of, we've spoken a fair bit there about heat pumps. Continuing on the all-electric home topic then, is there anything else that people need to understand with solar systems and maybe incorporating a battery about managing the time that they use the energy? Is there any strategic ways that we can go through that?
One of the things we would say is that even if you don't have solar, the most sustainable thing that you can do right now is use your use your energy during the day. Because if you look at the national energy market, so where our energy is coming from, you can see live data online at any point of the day. You will see that during the day, Australia is actually hugely renewable. We have heaps of solar. We generally have a small proportion of wind. And we were actually just reading news recently where there is a coal-fired power station experimenting with trying to turn itself off or run down during the day, which is incredibly hard.
They can't run them there's no need to run them during the day, but these sort of shut down and turn back on procedures are really challenging for a huge piece of infrastructure like that. And
the other thing is we want to use all that energy. So it's a great thing to use energy during the day. And so if you have solar, turn everything on or put it on automation for the daytime, your hot water particularly, but your dishwasher, clothes washing, dryer, and don't feel guilty about it. Use your free energy and feel good about using power. Like, it is an incredible thing that our houses are power stations. I mean, I don't think that we have enough wonder about what a miracle it is that we can do this. We would also
getting
say
free energy from the sun and using that in your house, and you have all the technology and infrastructure to do this. And there's people that are looking on their phone with an app to show them how they're using energy and turning things on and off. And I really think this is the future. And people that are not particularly into sustainability, but they're aware that this is really effective, and the cost of electricity, and thinking about anything that can run during the day, like a hot water system, that's actually a battery, because it's storing energy and it's going to release it in the morning or the evening or whenever you need to use that hot water. So it's essentially a battery that's scheduled, and then scheduling any other major appliances as well. So that's really the essential piece. And you could go further and say, well, actually, if you've got some east and west solar, that's going to help with the peaks of the energy demand, where typically a family will have higher peaks in the morning and then in the afternoon and evening. And so east and west solar is quite valuable. Even if it's producing less energy overall, it means you've got to store less and you've got it closer to the time of day when you're going to need it. And so that needs to be coupled with how much you're trying to store and what else you're trying to do. It's things like bulk heating and heating in the winter months, and especially at nighttime, that are going to use a lot of energy and be probably more than you can store in a battery system, certainly on, regularly. So that's where, getting the design right is fundamental.
So that's just great. It's such great information that, that's what we want to do. We want to get this out there, because if you're just thinking about building a standard Australian home, you quite often would just say wherever north is and slap the solar on and away you go. And people do have challenges with orientation sometimes. So, yeah, that's fantastic. Guys, I just want to steal a little phrase just talking through this, and I might read this just so I don't mess it up. We talk about a great framework for thinking about your home. Summer is for resilience and winter is for sustainability. Planning summer resilience in terms of building adaptability, shading, and building management plans. It's more specific to summer, but can you guys elaborate on that? I think that's fantastic.
Look, this is something that Andy came up with recently, and it's good to help us unpack for someone who's designing a home. What are the goalposts? What are we trying to achieve here? And so what we've really been talking about is the challenge in winter is, where is your energy coming from?
Let's cue the disclaimer. I need to let you know that myself and the Build Insite team are in no way, shape or form qualified to give you personal or specific business advice. We strongly encourage you seek out the use of professionals for products or when you are making personal or business decisions. Everything discussed during the Build Insite podcast is our own and the guest opinion and personal experience and is of a general nature only. Hope you enjoyed the episode. Catch you on the next one.